Hi guys, welcome back to ChemXplain again. This is the third episode of the Analytical Chemistry series. In this video, we are going to elaborate on some concepts such as density and specific gravity, and some more. And also to have a clearer understanding of these concepts, we are going to solve some problems together. Let's go. The first concept is density, which means the mass of a solution divided to its volume. Some common units of the density are grams per centimeters cube and kilograms per liter. You can also find some other units for density in different problems, but the most common ones are grams per centimeter cube and kilogram per liter. Let's head to the next concept, which is specific gravity. The definition says mass of a solution divided by mass of an equal volume of water at 4 degrees Celsius. You may think that this concept is not really understandable easily. I have to say that as we go through this episode, you get more familiar with it. It's also great to mention that for a specific gravity, we have no unit. It is just a number. Okay, to have a better understanding, let's head to the first example. The question says, calculate the molar concentration of HNO3 in a solution that has a specific gravity of 1.42 and is 70.5% of HNO3. As it is shown here, the molar mass of this solution is also given. Let's go. The question says specific gravity is 1.42, which means if we have 1 liter of the solution, the weight of the solution or of the weight of the sample will be 1,420 grams. And by knowing the percents of HNO3, we can easily calculate the amount of this acid. So let's go. We can say 1,420 grams times 70.5 divided by 100. If you calculate this, it says 1,001.1 grams. So this is the grams of HNO3 in this solution. By knowing the molar mass, we can say 1001.1 divided by 63. It will give us 15.98 moles of HNO3. So let's have a short review. We can say 1 liter of the sample solution is available, and in this 1 liter, there are 15.98 moles of HNO3. So in a conclusion, we can say 15.98 moles divided by 1 liter. It would be 15.98, or we can say 16 molars. Okay, let's have another example. It says, describe the preparation of 100 milliliters of 6 molar HCl from a concentrated solution that has a specific gravity of 1.18 and is 37% of HCl. Okay, we have the same strategy for this example. Let's say 1 liter of this solution weighs about 1,180 grams. Again, by knowing the percents of HCl, we can calculate the grams of HCl, which is 1,180 grams times 37 divided by 100, which would be 436.6 grams of HCl. Okay, now that we have the grams of HCl, it's better to calculate its moles. Let's go. We can say 436.6 grams of HCl divided by 36.6 grams per mole of HCl. Fine. The answer would be 11.96 moles. Okay, so again, we can say at the beginning we had 1 liter of the sample solution, and we found that in this 1 liter there are 11.96 moles of HCl. So the concentration of this solution is 11.96 molars, or in this case we can say 12 molars. Fine. So now that we have the concentration of the unknown solution, it's better to get to the next step. It says describe the preparation of this wanted solution. How much is the amount? It is 100 milliliters. And how much is the concentration? 6 molars. That's fine. So we can say that in 1,000 milliliters, there are 6 moles of the acid. So we can say in 100 milliliters, there are 0.6 moles of this acid. So the concentration that we calculated is 12 molars. We can say in 1,000 milliliters of this solution, there are 12 moles of acid. So how much solution should we have to have 0.6 moles of acid? This answer would be 50 milliliters of our unknown solution. So to answer this question, describing the preparation, we can say dilute 50 milliliters of the solution to 100 milliliters. That's it. Let's go to the next step. The example that we solved together is something really common in analytical chemistry. In action, when you're in laboratory in different situations, you may need to dilute a solution into a certain amount. So there should be a shorter way, an easier way to solve these problems. Let's take a quick look together at it. We can say the volume of the concentrated solution times the concentration of the concentrated solution equals the volume of diluted solution times the concentration of the diluted solution. In another word, or in a shorter way, we can say V1 times C1 equals V2 times C2. But let's check it together. Let's put the numbers in this equation. You can see here we want to prepare a solution, and the volume is 100 milliliters. The concentration is 6 molars. So the dilute solution is 100 milliliters times 6 molars. Okay, what about the concentration solution? The concentrated solution is 12 molars, and we need to find how much of this solution is needed to prepare the diluted solution. So we can say the concentration is 12 molars times the volume, which is not known to us. So to calculate the volume of concentrated solution, we can say 100 times 6 divided by 12. We can say this is 2, this is 1, and 100 divided by 2 is 50, or 50 milliliters. So the amount of acid, or the amount of the concentrated solution which we need to prepare the diluted solution is 50 milliliters. This whole process, this whole method is called dilution. Thank you so much. That is it for today's video. Hope you found it useful. Hit the like button and subscribe to our channel for more chemistry content. This is ChemXplain.